Yeah. So straight line and various form of the equation of the straight line. So generally in two dimension, in 2D, it is in two dimension the equation of the line is ax plus by plus c equal to 0. So in the two dimension, but it is in the three dimension. In the three dimension, in the three dimension, that is become x minus x1 by n equal to y minus y1 by m, so equal to z minus z1 by n. Okay, so this is x1 y1 z1. It is a passing point, so it is a passing point. And L M N and what is it? It is a DRS. Okay, now see, this is the symmetrical form. So there are two types will be there. So this is a equation to the line. So passing through the point x1 y1 z1 and having the direction cosines L comma M comma N. So that is become x minus x1 by L, y minus y1 by M, and z minus z1 by N. So this is called the symmetrical form of the uh, line equation. So what is the general form? So when we are getting to the line means, so the line means if the two planes are intersecting. So this is the pi 1 and this is the plane pi 2. So here this is intersecting, no? So this intersecting the common points of the two planes. So it is represented as line. Okay. So that's we can write pi 1 equal to 0 equal to pi 2. So this is called unsymmetrical form. Here is there. This is unsymmetrical form. So this is the symmetrical form of the line equations. Okay. Now let's do some problems about that. In the examination, this is a very important question. Equation to the line can be written as like symmetrical form. So symmetrical form means what is that? This one. X minus x1 by L, y minus y1 by M, z minus z1 by N. So this is a symmetrical form. So how we can change means here 2x plus 3 is 0. So let's take 2 is common. So that is become x plus 3 by here what is that? Minus 1 is there. So that 2 will become down. So that is become, yeah, x by 2. So x plus 3 by 2. So this is 2x plus 3 by minus 1. So take 2 is common. So that is become x plus 3 by 2 by 1. So x plus 3 by 2 by, here the minus 1 is there, sorry. So minus 1 by 2. So, so this is the symmetrical form. So in the same way here, 3 minus y by 4. So how we can write that 3 minus y by 4? So that's we can write, sorry, 3 minus y, that we can write minus of y minus 3 by 4. So y minus 3 by minus 4. So this is the one more thing. And next, 3z minus 1 by 2. So let's take 3 is common, z minus 1 by 3 by 2. Z minus 1 by 3 by 2 by 3. So this is a very important question. So when you are in the examination, so this is a very important problem. Okay. And here, find the image of the point on the plane. So this is the plane, and here should be point will be there, and we need to find that image of the point. So here this is 1 comma 3 comma 4, and this is 2x minus y plus z plus 3 equal to 0. So this is the one thing. Okay. Now, so this this is a plane. Okay. Now what is the direction ratios of normal line to the plane? So that is become 2 minus 1 1. Okay. And next, so how we are finding? So this is a point will be there 1 3 4. Now we are finding one line. Okay. So this is P and this is the Q. So we need to find the Q point. So we need to find the Q point. So first we are finding this is the normal line. So here the PQ is become what is that? That is normal line. Okay. So the equation, the line passing through the point 1 comma 3 comma 4 and having the DRS is 2 comma minus 1 comma 1. So this is the form. We know that no, x minus x1 by L, y minus y1 by M, z minus z1 by N. So this is a line equation. Now we are taking one that's 3 are equal to, let we are taking R. So from there, x minus 1 by 2 equal to R. So that is become x equal to 2R plus 1. And similarly, this is also y minus 3 by minus 1 equal to R. So y equal to minus R plus 3. So similarly, we are finding to z equal to also. So z equal to R plus 4. Okay. So this is the point of the Q. Okay. Now that point should be on lies on plane. Why? Because this is P and this is Q. So that Q point is must and should be in the line or a midpoint at that point only or midpoint. So if you are taking the midpoint of PQ, there should be lies on that uh, plane. So if you are getting that lies means we have to substitute there. So if we are substitute there in place of x, we have to substitute 2r plus 1 in place of 3, that is minus r plus 3, and next r plus 4. So we have to substitute in that equation. Okay. In that plane equation, then we are getting r equal to minus 2. So if you are substituting that r equal to minus 2, and we are getting the points P and P already, and R values we have to substitute in Q. So that is become minus 3 comma 5 comma 2. Understood? So this is the image of the point in the plane. So first we are finding one line. It's passing through the point 1 comma 3 comma 4, and we are taking some midpoint of that line that is also lies in that plane. So we have to substitute there. Then we are getting the R value. So R value we have to substitute in the Q point, and we are getting the Q. Now that Q is the image of the point P. Next, line through the 2 points. In the 2 dimension, equation to the line passing through the 2 points x1, y1 and x2, y2 is y minus m into x minus x1. So what is the m means? Y2 minus y1 by x2 minus x1. This is in 2 dimension. Okay. Now what is a 3 dimension means? So this is the x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. So here these are the become direction ratios. So which are the passing through the 2 points. Okay. Now, so this is the one problem is there. See equation to the line. Equation to the line passing through the 2 points. That is just now we discussed no x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Okay, so this is the formula for equation to the line passing through the 2 points. So this is x1 y1 z1, this is x2 y2 z2. Okay, now we have to substitute there and we are getting to that. And here in the line equation, the important that thing, unsymmetrical form to symmetrical form. This is a long question. They are giving to unsymmetrical form. Unsymmetrical form means they are giving the line equation with planes that pi 1 equal to 0 equal to pi 2. So if the line is represented by two planes, that is called unsymmetrical form. Now come to symmetrical form. X minus x1 by L equal to y minus y1 by m equal to z minus z1 by n. So this is the thing. So see, unsymmetrical force. Find the symmetrical form of the line. So this is the plane, and here also plane. So this is the line. Okay. So this is the plane pi 1, and this is the plane pi 2. Okay. Now we are taking this line. This is the line L1 normal to the plane pi 1, and this is the line L2 that normal to the plane pi 2. So this line, this L line is that perpendicular to L1, and L line is perpendicular to L2. Okay. So that's we are getting perpendicular. If the two lines are perpendicular, that A1 A2 plus B1 B2 plus C1 C2 equal to 0. So using that conditions, so we are getting A minus B plus C equal to 0, and 4A plus B minus 2C equal to 0. Now we need to solve these two equations, that A, B, C. Okay. So using these two equations, so we are getting values of A, B, C. How we can solve it? In the previous classes we studied it. If they are giving the two equations, how we are find the three variables. So using that thing, so we are getting that A value is minus 3, B value is 6, and C is minus 3. Thus we can write A1, B minus 2, and C is 1. Now we got it the direction ratios. Okay. Now we need find the point. So what is the symmetrical form line? We need the passing point, and we need the direction ratios. So already we find out the direction ratios. Okay, now we need to find the point. So before that, so we are taking one condition. We are putting the z equal to 0. That means the plane is intersecting xy plane. The line is in xy plane. XY plane means the z equal to should be what is that? 0. So z equal to 0. So z equal to 0 means in the equation 1 we have to substitute z equal to 0 here also. So then we are getting the two equations. So that is x plus y plus 1 equal to 0, and 4x plus y plus 2 equal to 0. Okay. And solving these two equations, then we are getting x equal to minus 1 by 3 and y equal to minus 2 by 3. So this is the x value, and this is a y value. And finally, we are getting the z value is automatically, that is 0. So minus 1 by 3 minus 2 by 3, 0. That is the point on the line. Okay. Next, from we have the DRS, that is we have that 1 comma minus 2 comma 1, and we have the point. Now from there we can find the symmetrical form x minus x1 by L, y minus y1 by M, and z minus z1 by N. So then we are getting that x plus 1 by 3 by 1, and y plus 2 by 3 by minus 2, and z by 1. So this we are getting that. Okay, so this is important. So unsymmetrical form to symmetrical form is important for the long answer. So this is that practice questions. You need to practice. Next, angle between a plane and line. Okay, so this is the line L1 and this is a plane phi1. So now we need to find angle. So that is, so this is cos 90 minus theta, that is sine theta. So sine theta equal to AL plus BM plus CN by under root of A square plus B square plus C square into under root of L square plus M square plus N square. So this is that angle between the plane and line. See, if the plane and line both are parallel, so like this. So this is the plane and this is the line L1. If both are parallel, so that we are getting AL plus BM plus CN equal to 0. AL plus BM plus CN equal to 0. That is, so here the one problem is there. So find the angle between x plus 1 by 2 equal to y by 3 equal to z minus 3 by 6 and the plane 3x plus y plus z equal to 7. Okay. Now the direction ratio of the line 2 comma 3 comma 6 and direction mention of this is become L M N and this is become A B C. So cos theta equal to AL plus BM plus CN by under root of A square plus B square plus C square into under root of A square plus M square plus N square. So using that formula, you need to find this one. Now up to now we find out angle between line and plane. Now we are going to discuss the point of intersection of the line with the plane. The point of intersection of the plane with the line. So that we need to find out. So this is the line and this is the plane. Okay. Mm. So find the coordinate point of intersection of the line x plus 1 by 1 and y plus 3 by 2, z minus 2 by 2 with the plane 3x plus 4y plus 5z equal to 5. Okay. Mm. Now we need to intersection of the point. So this is a line L1 and this is the plane pi 1. So this is we are taking that intersection, no? Okay. This we need to find the point. Uh, Next, this is x plus 1 by 1, y plus 3 by 3, z minus 2 by 2 equal to r. So, so this is x equal to r minus 1 and y equal to 3r minus 3 and z equal to minus 2r plus 2. So that's we are getting, this is the point. So this point is also lies on that plane. Why? Because this line and plane. So the point is common for the line and the point is common for the plane also. So that point is must and should be on the plane. So we are getting this one. Okay. So if we are substituting that point in the plane, so we are getting this one. R equal to 2. So this is the point. It is 1 comma 3 comma minus 2. Okay, so this is the point, the intersection point of the line and plane. So here the one problem is that they are giving the line and plane. So we are getting the point of intersection. And the one more topic is condition for line lies on plane. Plane and this is the line. So it should be lies on that one. So we do that thing.